Longer I prepare for the live stream, the worse it is, or well, it's not necessarily better. So might as well just jump into it. Luckily we have the website that can guide us, so this should pretty much have everything we need. Everything we're talking about is either already here or going to be published on bionicchaos.com fairly soon. Okay, we might as well start talking to the robot as well, because there is no human currently readily available. I don't have a budget to pay a human, but I do have a budget to pay a bunch of robots, so I might as well use them. Potentially even for co-hosting this live stream, if you like. If you want to be telling jokes or whatever, go for it. Just make sure they are on topic. Perhaps during live stream, do short responses. Short responses as well. Trouble. I bet people start speaking English. Yeah, don't like dot points. Okay, do you think people will start speaking English in a way that a speech-to-text algorithm can understand them better in the future? Also, can you avoid dot points in your responses? Yeah, just to save history as well. It's not doing that anymore. And it's not reading straight away. They will have to read when the response is available.
That as speech-to-text technology becomes more integrated into daily life, people might naturally adjust their speaking habits to be more easily understood by these algorithms.
One sec. Right, that should be a bit better.
It's quite likely that as speech-to-text technology becomes more integrated into daily life, people might naturally adjust their speaking habits to be more easily understood by these algorithms. This could include speaking more clearly, enunciating words better, and perhaps even avoiding slang or ambiguous terms. In addition, as these algorithms improve, they will likely become better at understanding a wider range of accents, speech patterns, and contexts, reducing the need for people to change the way they speak significantly. The interplay between human adaptation and technological advancement will shape how this evolves. If you have any more specific questions or need help with anything else, feel free to ask.
Again, can you keep responses shorter? We are shorter. What? Clear doesn't work. Is it clear? No, it was another add-on. I don't know why I have to use an add-on. Why OpenAI is not just introducing this stuff on the website as well, considering they have it all in the mobile app. Why do desktop users miss out? It keeps again dot points. I said no dot points. Is that okay by you? Have to be nice to the bots before they take over, start kicking ass.
Got it. No dot points. Here's a more integrated response. Yes,
Integrated.
we can provide shorter and clearer responses. Regarding add-ons versus integrated features, add-ons are often quicker to deploy and update without needing to alter the core application. However, integrating features directly into the website or app ensures that all users have access without needing extra steps. It's important to ensure that desktop users do not miss out on features that are available in mobile apps. Ensuring feature parity across platforms enhances user experience and satisfaction. Let me know if you need anything else.
I think I need to stop talking for the text to actually appear. I must have gave an error. Yeah, it gave a bunch of errors. I don't know, that's for the Google ads. Yeah, we are using an ad blocker. Someone was complaining about the amount of ads on the website. Well, yeah, it's a never-ending debate, is it? Yeah, but speech recognition error aborted. That's an important one. Yeah, we'll have to restart the page, test it again, see if it's still working. Yeah, it is working fine. Is it any better than the Chrome add-on that we use? Maybe. I don't know if it's timing out or something, this one. I think it does. It's like trying to save resources on your machine and stuff like that. And so that's something we have. Yeah, the ad blocker blocked 2 ads. I think there might be like a banner and another, in text something. Yeah, there's also videos in it that will actually show you how I use the app, whatever. Normally the idea is we should on every page have one over here as well, and this would not work because I'm using my camera. That's pretty annoying, using my camera for the streaming, so this would not work. Anyway, so you will have to test it for me, but yes, there is a video of me using the application, and eventually there will be a video on every page. And yes, there were 3 ads blocked on this page. I don't know if it's too much, probably should have been 1 or 2. 3 might be turning users away, but then it's a free content, so bear with me. We do have a Patreon page if you are interested. Let's jump into development and go over what's currently available later on. Let's go through. So we have a bunch of things in the works. Might as well give it to the bot as well. By the way, there's a custom GPT, which I'm not sure how well does it work. This is the current tools that we are working on. The top one is the most recent. Some of them were already published. Essentially, we want to publish them all on bionichaos.com. I think you should know everything about it by now. Or should I be using the custom GPT that was trained on the website's content? What do you reckon? Also, keep responses short. Don't mind you trying to be funny, but stay on topic. Sometimes it goes into different modes. That's okay. Humans do that as well.
To publish all your tools on bionichaos.com, integrating them as features directly on the site would be ideal. Using a custom GPT trained on your website's content could enhance user interaction by providing tailored responses based on your tools and data. Since the top one, Wheelchair, is already published, you can follow a similar process for the others. Ensure each tool is accessible from a user-friendly interface on your site. This can involve 1. Creating dedicated pages or sections for each tool. 2. Providing clear instructions and descriptions for users. 3. Ensuring feature parity across desktop and mobile versions of the site. By using a custom GPT model, you can make interactions more relevant and helpful, enhancing the overall user experience. Let me know if you need help with specific steps or have any questions.
Yeah, let's quickly go over them if we get stuck with just be moving on to the next one. Oops. What do we have? We have the FIT data. So we're trying to extract those FIT files that you have on your wearable devices. It's called FIT data. We can make this smaller. We normally have an info file. Create a Flask application. It's a single page application. Should allow users to upload FIT files and process it client side using JavaScript. Yeah, we had some trouble doing that. We might change the approach. Basic structure. I don't know what all that stuff. We don't actually need that. It's not called the common data app. It's called the FIT data. We should change that. We need all the capital letters correct. Yeah, that's what it's called. A project structure. I'll provide you with some code and description of a project. We would like, however, to use another AI to actually generate the code. So we are using Visual Studio Code. We are using GitHub Copilot in it. So if you could provide instructions for the other robot to do the coding, that would be great. How does that sound? Here is also some of the information for the project below. The spelling mistakes are okay, because the speech to text is not great. Okay, I don't know what's going on with you today. You're not listening. I said don't actually generate the code. We have another AI doing the coding. If it starts generating the code with 4 node, I want to quickly try GPT-4. I also asked for no dot points. No dot points. It's actually adding a full stop. I asked no dot points in your responses. It's like in the programming mode or something. Yeah, let's read this quickly.
Understood. Here's a detailed step-by-step description without using dot points. For the Flask setup in app.py, instruct the AI to create a Flask instance. It should then define a route to serve the index.html file from the templates folder. Ensure that static files are accessible by configuring Flask to serve them from the static directory. In the index.html file, start by setting up the basic HTML structure. Include a doctype declaration and meta tags for character encoding. Link to the style.css file located in the static CSS directory and to the app.js file located in the static/js directory. Include the FIT File Parser library via a CDN for parsing FIT files. Add an input element of type file for file uploads and a button element to trigger the file parsing. Include a pre-element to display the parse data. For the JavaScript file app.js, add an event listener to the button to trigger a function that handles file parsing. Use the File Reader API to read the selected file. If no file is selected, fetch the default FIT file using the Fetch API. Use the FIT File Parser library to parse the FIT file data and display the parse data in the pre-element. For the CSS file style.css, add basic styling to the body, header, input, and button elements to ensure a clean and user-friendly interface. These instructions should guide GitHub Copilot to generate the required code.
Okay, I also realized the structure is actually not updated. So we'll use GitHub Copilot to update the structure. We need the workspace handle and see if it can do it. We actually have a few example files. You want to see it? They actually should be included. They should be included. Yeah, this is better. Yeah, it keeps reverting to a using virtual environment. We have the whole a machine dedicated for this project. So we have a whole machine dedicated for this project, so we do not need to use virtual environments. And we don't actually, yeah, at this stage. Okay, also at this stage, we would not have a upload file option. We do have some example files in the data folder. We don't actually have that one. I don't know what it's talking about. Get rid of it. Yeah, so we had issues with that FIT parse JavaScript file before. Don't think it's actually working. And let's add this as a prompt. So we might have an issue with the FIT parse mean JavaScript file. So yeah, the text to speech is annoying. I might have to use CDN for this, but maybe we did get it from a CDN. We did get it from a CDN, but might need to download and put it in the to test. Yeah, test it out. That's right. This updated project structure. Obviously, that's the Flask backend, but yes, it's currently not doing anything or not doing much. It's essentially just serving the HTML. Yeah, this HTML could use updating. We have the app.js is primarily what we rely on. The bot should know that, well, because it has most of the code. Yeah, this minified, we might need to use the original FIT parser.js. Okay, now question. We're currently using a FIT parser mean.js. However, should we use the original full FIT parser.js instead? Let me know what you think. Keep responses short. Yeah, while it's generating, go check out the website, chaos.com, and pretty much all the tools that we are developing in the moment will appear on this site as well. So that not to generate code, but it still does this funny bit.
Using the full FIT parser.js instead of the minified version can be helpful for debugging and ensuring compatibility. If you're experiencing issues with the minified version, switching to the full version might resolve them. Test both versions to see which one works best for your needs.
Yeah, I like the short response, but it's not actually helping, is it? Let's pop it into Copilot workspace handle, see what it says. I don't know if it can find the original JavaScript file. It says, I'm sorry, I can't answer that question. Okay, back to code development mode. can you generate the HTML with the appropriate FIT parser JavaScript file? Okay, we have the HTML. Yeah, we have the styles. Yes, even though we have one for the whole project, we'll fix it later. Yeah, so we're not uploading FIT files anymore. Yeah, we have a button. That's okay. We need to, yeah, remember it wasn't working previously, so check if this FIT parser is actually there. It seems to be okay. We'll run the application in a second, see what it does. So loading it from a CDN, we also have our app.js. That's okay. Potentially we do not need the FIT parser mean anymore. Are we actually using it somewhere? No. Where is the FIT parsing actually happening? Oh, come on. GitHub copy. Where's the FIT? Where is the FIT parsing should be actually happening? We would like to do as much as possible in the front end. Copilot doesn't have the bigger picture. It's a bit annoying. Okay, it's just generating the code for us while I'm struggling with GitHub Copilot. Because you have to be absolutely precise with it, with prompting it. Okay, we have parse FIT done. That's not it, is it? This JavaScript file is also unusual. Handles the input, treats the selected file, or fetches a default file. Okay. FIT parser library, parse data is in the pre element. This wouldn't work, would it? But there is only one way to tell by running. It's trying to fetch default FIT, which we don't actually have. It's actually trying to parse a FIT file, which we don't currently have. See above which files we do have in the data folder. Could we just fix the necessary code? Perhaps do not generate the whole code from scratch at this stage. Keeps generating code. Okay, JavaScript. It is generating the whole thing, isn't it? Okay, we have the file. Still getting an error. This will attempt to fetch the parse available FIT file, so the file is there, that's fine. Yep, we had a similar error before. Can actually try. Ooh, I was pretty sure I was able to switch between models before. Doesn't support file attachments. Let's keep suggesting. Why are we using instead of the original?
The error indicates that the FIT parser is not being recognized correctly. This might be due to the minified version of the library or incorrect usage. To address this, let's use the original full FIT parser.js and ensure it's correctly integrated. Steps to fix the issue. 1. Download the full version of FIT parser.js and place it in your static js/directory. 2. Update the HTML to use the local version of FIT parser.js. Updated project structure. Plain text fit data/app.py templates index.html static js fit parser.js. Full version of the library. App.js. Contains logic for parsing FIT files client-side. CSS style.css. Basic styling for the SPA, data 2024-527-43-51.fit. Additional fit files, optional. Garmin-edge-500 activity.fit, hash. Additional fit files, optional. Updated HTML file, index.html. HTML length head. Pedimeta charsi viewport, content width device width, initial scale 1.0 processor. Link rel style sheet ref URL 4 static file name equals css/style.css. FIT file processor input type file ID file input. Parse fit file put. Include the local fit parser library. Script sarc URL for static file name equals js/fitparser.jag. File name equals js app.js. Ensure fitparser.js is correctly integrated. Make sure that the fitparser.js file is the correct library and is correctly placed in the static js/ directory. Verify JavaScript app.js. Ensure that the JavaScript code is correct and compatible with the fitparser.js library. JavaScript document.addEventListener DOM content loaded event if document.getElementById file input files.length fetch default file function parse fit file const file input equals document get element by id file input const file equals file input file 0 const output element equals document.get element by id output if file read file file else fetch default file function read file file const reader equals new file reader reader.onload equals function event const array buffer equals event.target result parse fit data array buffer reader.read as of array buffer and fetch default file fetch/static/data 2024.527-4351.fit update to the correct file path, then response equals response.arraybuffer, then arraybuffer, parse fit data arraybuffer dot catch error, document.get element by id output dot text content equals error loading default file doll error, function parse fit data array buffer, const output element document.get element by output, const fit parser equals new fit parser, force true, speed unit km is per h, length unit m, temperature unit Celsius, elapsed record field true, mode list. Fit parser dot parse aramis array buffer, function error data, if error, output element dot text content equals error $, else output element text content json dot stringify data null 2. By using the full version of the fitparser.js library and ensuring it is correctly referenced in your HTML file, you should be able to avoid the type error, fit parser is not a constructor error. If you encounter any further issues, make sure that the fitparser.js library is correctly implemented and that your JavaScript code matches its expected usage. The error uncaught reference error, exports is not defined, indicates that the fitparser.js library is being used in a context where Node.js module system syntax, exports, is not recognized by the browser. This typically happens when trying to use a Node.js module directly in the browser without proper packaging. To fix this, you can use a browser-compatible version of the FIT File Parser library. Let's use a known working version of fitparser.js designed for the browser environment. You can get the browser-compatible version from a CDN like JSDeliver. Updated HTML file, index.html. Modify the HTML file to include the proper library. HTML doctype htn head. Meta charset, UT8, meta name viewport, content width device width, initial scale processor, link rel style sheet href, URL for static, file name equals css/style.css body, h1 file processor, input type file, idle file in button one click parse fit file, parse fit file. Include the browser compatible fit parser library from JDeliver CDN, script cdn.jsdeliver.net/npm/fit file parser at 1.8.dist/fit parse for static file name js stat app file JavaScript file js. Ensure the JavaScript code for parsing fit files is compatible with the library. JavaScript document.addEventListener DOM content loaded if document.get element by id file input files.length fetch default file. Function parse fit file, const file input equals document get element by id file input. The error indicates that the library you're trying to use is not suitable for the browser environment directly. Let's try using a different approach by leveraging a browser-compatible library or converting the current library into a format that can be used in the browser. To resolve this issue, we will use a proper version of the FIT parser that is meant to be used in the browser. We can use a known FIT parser like FIT.js that is designed to work in the browser. Here's how to update your code to use FIT.js. --update HTML file index.html. Use the FIT.js library, which is designed for use in the browser. HTML doctype HTML head metadata charset UTU port content width device width initial scale 1 FIT file processor link rel style sheet URL for static file name css style.css body h1 FIT file processor input type file id file input button parse FIT file output. Include the browser compatible FIT parser library from JSDeliver CDN. script/cdn.jsdeliver.net/npf-dist/fit.min.script. URL for static file name js-app.js. Update JavaScript file app.js. Ensure the JavaScript code for parsing FIT files is compatible with the library. JavaScript document.add-event-listener DOM content loaded event equal. If document.getElementById file input files. Given that you're seeing the exports is not defined error, it means that the FIT parser.js you are using is not designed for direct inclusion in the browser environment. Let's use a different FIT parser library that's designed for the browser. You can use FIT.js, which is known to work well in browser environments. Here's the correct way to set it up. #update HTML file.html, HTML lang equal UTF-8, meta name viewport content device width initial scale 1 FIT file processor. Link URL for static file name css//style.css input type file id file input button one click parse FIT file pre-id output. Include the FIT.js library. Script cdn.jsdeliver.net/FIT file fitch-parser at 19.5/FIT parser.py. Script to see URL for static file name equals js-app.js. JavaScript file app.js. Ensure the JavaScript code for parsing FIT files is compatible with the library. JavaScript document.add-event-listener DOM content loaded event. If document get element by id files.length fetch default file. Function parse FIT file. Const file input equals document.getElementById file input. Const file equals file input.file. Const output element equals document get element by id output. If file read file else fetch default file. Function read file const reader equals new file reader. Reader.onload equals function event. Const array buffer equals event.target result. Parse FIT data array buffer. Reader.read as array buffer file. Function. Given the error, we need to use a version of the FIT parser library that is browser compatible. The library you are currently trying to use is designed for Node.js environments. Let's switch to a different FIT file parser library that is designed for browser usage. FIT.js is a suitable option. Below is the updated code using FIT.js. Updated HTML file index.html. HTML doctype HTML head meta charset UTF-8 meta name viewport content width device width initial scale 1 point file process style sheet URL for static file name will css style.css body 8 FIT file processor input type file input button one click parse FIT file button include the FIT.js library. Encrypt src tps/cdn.jsdeliver.net/dist fit.min.js. Dist gul for static file name js. Updated JavaScript file app.js. Ensure the JavaScript code for parsing FIT compatible with FIT.js. JavaScript document.add-event-listener DOM content loaded event equals. If document get element by id file input.files input fetch default file. Function parse FIT file. Const file input equals document get element by id file input. Const file equals file input dot files 0. Const output element equals document.get element by output. If read file else fetch default file. Function read file const reader equals new file reader. Reader.onload equals function event. Const array buffer event.target result. Parse FIT data array buffer. Reader.read as array buffer file. Function fetch default file. Fetch/static data 22.405.27-743.51. Then response equals response.array buffer. Then array buffer equals parse FIT data array buffer. Catch error equals document.get element by id output.text content error loading default file error. Function parse FIT data array buffer. It appears there may have been an issue with the FIT.js library fetch. Let's instead use the FIT file parser correctly by transforming it into a format suitable for browser usage. Here's how you can adjust your project. 1. Bundle the FIT file parser library for browser use using a tool like Webpack or Browserify. To simplify this, I will outline how to use Browserify to transform the Node.js module into a format that the browser can use. Like step-by-step instructions. 1. Install Browserify in Babel. First, ensure you have Node.js installed. Then install Browserify in Babel, sh npm install g.
Is it possible by any chance to pass the FIT file ourselves? Keeps coming up with these libraries. None of these libraries actually seem to work. They don't have the JavaScript file. How hard would it be to process the data files from scratch in JavaScript ourselves? Those should be common data format. Yeah, pass the header, passing the data records. Let's read this.
Processing FIT files from scratch in JavaScript can be challenging due to the complexity of the FIT file format, which is a binary file format used primarily for storing fitness data. However, it is possible to write a custom parser to handle the basic structure of these files. Here's a simplified outline of how you could start building a basic FIT file parser in JavaScript. Understanding FIT file structure. FIT files consist of a header, record definitions, and data records. Each record can contain multiple fields, which can vary in size and type. Steps to build a basic FIT file parser. 1. Read the binary data. Use the File Reader API to read the file as an array buffer. 2. Parse the header. The FIT file header typically contains a header size, protocol version, profile version, data size, and a CRC checksum. 3. Parse record definitions. Record definitions describe the format of the data records that follow. 4. Parse data records. Data records contain the actual fitness data, such as timestamps, latitude, longitude, speed, heart rate, etc. Example code. Here's a basic example to get you started with reading and parsing a FIT file. HTML file index.html. HTML.html lang head. Meta charset u viewport content width device width initial scale 1 point FIT file processor title link rel style.
Okay, that didn't quite work, but I like the idea of processing the data files from scratch using basic functions. Now, can we make sure the header data is displayed on the front page and fix the above error? Hopeless. Just send it as is. It's normally quite forgiving. Just changing the HTML wouldn't work, would it? I have to change the whole front end code as well. Right, so we have header size 14, protocol version 16, profile version. Yeah, we have this Ava file as well. Okay, so the older file that I had somewhere online, I think it was on GitHub somewhere, is a header size 14, protocol version 16, 14.6. Let's take an image of this quickly, and then we have the another one. So the original the profile version data size was at 16, 105. Why are they the same? I don't know. Could use more details. Yeah, I think that choose file doesn't actually work. We need some sort of drop down. It's interested in ensuring that properly handle the offset and account for the end of the data view correctly. So why it's generating the whole code again. What changes were made, information extracted, error handling, offset adjustment, okay. Okay, it added about like 2 lines of code. Didn't actually help, did it? I'm not getting any errors, nothing major. But that's fine, we don't care about that error for now. Hey, we are getting the same result as before. Can we make sure we're actually showing more, or essentially all the available information about the data file on the front page? Also trying to understand why is this error is not shown in the browser console.
Let's improve the script to display all available information about the FIT file and ensure any errors are visible in the browser console. We'll make sure to handle the offset properly and display detailed information about each part of the FIT file. Updated HTML file, index.html, HTML .prying in head, meta charset UTF-8, viewport, content width, device width, initial scale 1, title, FIT file processor. Link rel style sheet, shref, URL static, file css/style.css, FIT file processor, input type file input, button 1 stacked, button parse FIT file, pre-ID header output, real name JS static signing file, updated JavaScript file.js, JavaScript document.add.dom content loaded, event. If document get element by id file input files.length, fetch default file, function parse FIT file, const file input document.get element by I input, const file equals file input file 0, const output element equals document get element by id output, const header output element document get element by output put.
Hey, I'm still getting the same error. Can you give a general quick overview of how are you trying to fix this problem? I get GitHub Copilot is saying outside the bounds, propose fix, check bounds before accessing the data, updated code, adjust skipping logic for other record types. Skipping. GitHub Copilot did something better. Can we switch? Yeah, we can switch models now without starting a new chat. Let's see what GPT-4 does. I did notice before that it is producing slightly better results than 4.0.
The error message you're seeing, offset is outside the bounds of the data view, suggests that we're still not correctly managing the offset boundaries. This could be due to an incorrect assumption about the record sizes or the data structure of the FIT file. We need to ensure that the offset does not exceed the total byte length of the file. Let's refine the approach to handle the records properly by avoiding any assumptions about record size unless they're explicitly defined, and let's add a better structure to manage the records. Revise JavaScript code, ape.js, JavaScript document.addEventListener, DOM content loaded. If specific record types need parsing, further customization will be necessary according to the FIT file specification.
Well, all right, yeah, GPT-4 was able to do better than 4.0, whatever it's called. Yeah, I don't know why I can't read that specific bit. Can you quickly summarize the changes that were made to the code without generating any new code? Also, in future responses, is it possible to generate all the text first and the code later? This is because I'm using a text-to-speech and would like the text to be read first.
Absolutely. Here's a summary of the changes made to the code in the previous response. 1. Improved offset handling. To avoid the offset is outside the bounds of the data view error, checks were added to ensure the offset does not exceed the allowable byte length of the data view. This is crucial when parsing sections of the file, specifically to make sure we do not read beyond the actual data size minus the CRC at the end. 2. Header information parsing and display. The script correctly parses the FIT file header, which includes extracting and displaying values like header size, protocol version, profile version, data size, and file type. This information is displayed in a separate section on the web page, helping to debug and understand the structure of the FIT file quickly. 3. Record handling and parsing logic. The script introduces a basic structure to manage different record types found in the FIT file. While still simplified, this structure checks the type of each record and adjusts the offset accordingly. This framework is set up to facilitate detailed parsing based on specific FIT file specifications, which would need to be expanded to fully handle all types of data contained in such files. Enhanced error handling was added to catch and display errors in both the web page and the browser console. This makes debugging easier by providing immediate feedback on what might be going wrong when the script encounters unexpected data or reaches the end of the file prematurely. Boundary and safety checks. Additional safety checks were implemented before attempting to read data to ensure the script does not attempt to read beyond the end of the file, especially considering the data size and header size, to avoid including the CRC in the data parsing section. This approach helps stabilize the data parsing process and provides a foundation for further development to accommodate more complex structures within FIT files. For future responses, I'll make sure to present explanations and summaries first, followed by any code samples or technical details. This should help with clarity, especially when using text-to-speech technology.
Seem to be parsing the data correctly, but we would like to actually be able to tell what is inside the data file and eventually display it as useful charts.
Great to hear that the parsing is going well. To make the data from the FIT file more understandable and ultimately visualize it as useful charts, you'll need to take several steps. 1. Understand the FIT file structure. FIT files are structured with a variety of data messages, each representing different types of data like sessions, laps, records, events, etc. Each type of message has specific fields associated with it, e.g. heart rate, position, altitude, speed. Understanding the specifics of these data messages and their fields is crucial for correctly interpreting the data. 2. Map data fields to meaningful names. Currently, the data is being parsed as generic fields, like field 1. You'll need to map these fields to their meaningful names based on the FIT file specification. This requires identifying the type of each data record, e.g. session, event, and then mapping the record's contents to their respective fields. 3. Data transformation. Convert the raw binary or numeric data into meaningful units, e.g. converting speed from m/second to kilometers per hour, or time from seconds since UTC to a readable date-time format. 4. Data storage. Store the parsed and transformed data in a structured format like an array of objects where each object represents a data record with clearly named properties. 5. Visualization. Use JavaScript libraries like Chart.js, D3.js, or Google Charts to create visual representations of the data. You'll pass the structured data into these libraries to generate charts such as line graphs for heart rate over time, bar charts for lap speeds, or maps for routes. Example approach to enhance current script. Let's consider you have identified that field 1 in your current output actually represents the timestamp, and you want to map and visualize it. 1. Enhance data parsing logic. Modify your parsing logic to check the message type and map the fields to more descriptive names. 2. Example data mapping. Suppose each record includes a timestamp and heart rate. You could create objects like timestamp, heart rate. 3. Visualization script. Here's a conceptual approach to use Chart.js for visualizing heart rate over time. JavaScript assuming.
That's okay. There's some great ideas. Is there a way to actually know what each field is from the data in the file itself? Doesn't have a description for each field. A quick response will be great. Also, if you feel like making a relevant joke on topic, go for it.
The FIT, Flexible and Interoperable Data Transfer file format developed by Garmin organizes data in a highly structured way, but doesn't include descriptive field names directly in the file itself. Instead, each field is identified by a number, and the meaning of these numbers is defined in the FIT file specification, which is like a dictionary for decoding the data. To understand what each field represents, you'd typically need access to the FIT profile, which outlines the structure of different message types and their corresponding fields. Garmin provides a FIT SDK that includes a profile in .h and .xml formats, detailing each possible field and its meaning. Developers can use this SDK to correctly interpret the data by mapping numeric field identifiers to their defined purpose, e.g. heart rate, latitude, longitude, speed, etc. Here's a quick way to remember this. Just like you wouldn't read a medical test report without knowing what the tests were for, you wouldn't parse a FIT file without the FIT profile. It's all about having the right dictionary. Joke. Why do programmers like to parse their coffee before drinking? Because they like to handle exceptions properly before it's too late. Practical approach. 1. Download the FIT SDK from Garmin. This contains the profile definitions required to interpret the fields correctly. 2. Use a FIT parsing library. Libraries like FIT File Parser in JavaScript or others in different languages often come with capabilities to automatically map these fields based on the profile. 3. Manual parsing. If you're manually parsing the file, you'll use the SDK's profile as a reference to map each field number to its name and decode the data accordingly. By integrating such methods, you can ensure that the data you extract is meaningful and correctly represents the intended metrics, making your analysis or application much more reliable and insightful.
Yeah, we do have an information. There's a bunch of tools. I don't know why I need the SDK. Yeah, it was released like a month ago. That's fine. Okay, a couple questions. Things that I don't understand. Why do I need to download the SDK? Is it just for getting the data from the device? Because I already got the data files from the device. Moving forward, I am doing manual parsing. So would the profile be essentially a text file explaining what each field is? I found the following the description online. Could you explain what does it all mean? Well, time me out eventually because I'm bombarding it.
Sure, let's break down the information and usage of the Garmin FIT JavaScript SDK as you've described, making it more digestible. Here's an explanation of the key elements and functionalities. Overview. The FIT JavaScript SDK is designed to parse FIT files, which are binary files primarily used by Garmin devices to store activity data. It uses modern JavaScript features and requires an ECMAScript-compatible environment, such as Node.js v14.0 or higher or modern web browsers. To use the SDK in your project, you need to install it via npm, Node Package Manager, which is the package manager for JavaScript. By running npm install at garmin/fitsdk, the FIT SDK will be added to your project, allowing you to use its modules to decode FIT files. Basic usage. The FIT SDK offers several classes and utilities for working with FIT files. 1. Decoder. This class is used to read and decode the data from FIT files. It processes the binary data, validates it, and converts it into a more usable format. 2. Stream. This class handles the binary stream of data from the FIT file. It can be initialized from different sources like byte arrays or buffers. 3. Profile and utils. These are used for additional configurations and utility functions such as converting date and time formats. Key methods and their explanations. IsFit. Checks if the loaded data conforms to the FIT file format, specifically checking for the FIT signature in the header. Check integrity. Verifies the integrity of the FIT file by ensuring the header's file type signature is correct. The file size matches the header specification, and the computed CRC matches the one listed in the file. Read decodes all the messages from the FIT file, returning an object containing any errors encountered and a dictionary of decoded messages grouped by type. Practical implementation. Here's how you can use the FIT SDK in a typical scenario. 1. Create a stream from a binary source like an array buffer representing the FIT file. 2. Instantiate a decoder with this stream. 3. Use the decoder to check if the stream is a valid FIT file and then read the data. This process will decode the data, handling various aspects like scaling, offset adjustments, subfields, and component expansion based on the FIT profile. Why download the SDK? Even though you already have FIT files, the SDK is crucial because it contains the logic and definitions necessary to interpret these files correctly. The FIT profile, which is part of the SDK, defines what each data field in a FIT file represents and how to properly decode it. This is essential for translating the raw binary data into meaningful information. Example of decoding and error handling. Here's a simplified example of using the SDK. JavaScript import decoder stream from @garmin/fitsdk. Const bytes equals byte array from a FIT file. Const stream equals stream.fromByteArray bytes. Const decoder equals new decoder stream. If decoder.isFit, const messages errors equals decoder.read. If errors length, console.error errors errors. Else console.log decoded messages messages. Else console.log this is not a valid FIT file. This setup checks if the file is a FIT file, reads it, and logs the decoded messages or any errors that occurred during the decoding process. In summary, understanding and using the Garmin FIT SDK involves setting up the appropriate environment, utilizing the SDK's classes to read and validate FIT files, and handling the decoded data as per your application's requirements. This SDK simplifies working with FIT files by abstracting the complexities of direct binary manipulations.
Okay, I still don't get why I need to download and run the SDK. I already have the data files. Now, the FIT protocol is available on the website as well. A copy of it is below. Can you browse the following?
The FIT Flexible and Interoperable Data Transfer Protocol is a standard developed by Garmin for the storage and sharing of activity data from various devices. Here's why you might still consider using the SDK even though you already have the data files. 1. Understanding the data structure. The FIT protocol is designed to be compact and efficient, using predefined messages that correspond to different data types, like activity records, event types, etc. Each message contains specific fields that represent the data points. The SDK provides the necessary tools and documentation to understand these structures, decode them correctly, and utilize them in your software. Decoding the files. While you can manually parse FIT files, the SDK includes libraries that handle the decoding automatically, managing nuances like data type conversions, endianness, and compression. This can significantly simplify your development process. 3. Profile definitions. The SDK includes the global profile definitions, which are crucial for interpreting the data correctly. These definitions tell you what each field in a message represents, e.g., heart rate, latitude, speed, and how to convert raw data into usable information. 4. Maintaining compatibility and extensibility. FIT files are designed to be forward compatible and extensible. The SDK helps ensure that your application can handle new types of messages or fields that might be introduced in future versions of the FIT protocol. 5. Efficient data use. The SDK can help you efficiently process and generate FIT files, ensuring that your application can read from and write to FIT files in a manner that is consistent with other applications and devices. Here's a basic overview of the FIT file protocol as described in the documentation. File structure. A FIT file is composed of a series of messages that store data. These messages are defined in a global profile and can include any data relevant to fitness activities such as heart rate or GPS location. Messages and fields. Each message in a FIT file contains several fields, and each field has a specific data type and meaning. For example, a message might record an activity with fields for start time, end time, and calories burned. Decoding messages. The SDK provides tools to decode these messages based on the definitions in the global profile. This is essential for turning the raw binary data in a FIT file into meaningful information. Extensibility. New types of data can be added to the FIT protocol without breaking compatibility with older versions. This makes it a robust choice for long-term projects. Using the SDK isn't just about accessing the data, it's also about understanding it fully and integrating it seamlessly into your applications with minimal risk of misinterpretation or error. The SDK provides the tools and documentation necessary to handle FIT files according to the standards set by Garmin, which can be especially important for ensuring compatibility across different devices and software systems.
Still don't understand a couple of things. First of all, is the FIT file used by other manufacturers? Is it just a general file, or is it proprietary to Garmin? I think not. Also, what exact information is available in the header file? Isn't it telling me what each bit of the data, whatever field, whatever it's called, actually holds? A quick response will be great.
The FIT, Flexible and Interoperable Data Transfer File Format, is not proprietary to Garmin, but was developed by Garmin and is widely used in the industry, especially for sports and fitness devices. It's designed to be a standard that various manufacturers can adopt to ensure compatibility and interoperability of data across different devices and platforms. While Garmin spearheaded its development and provides tools for its use, other manufacturers and developers can use and implement FIT protocols in their devices and software. Shab, what's in a FIT file header? The header of a FIT file contains critical information about the file itself, which helps in parsing and interpreting the rest of the data correctly. Here's what's typically included in a FIT file header. 1. Header size indicates the size of the header itself. 2. Protocol version specifies the version of the FIT protocol used, which helps in determining how the data should be interpreted. 3. Profile version relates to the version of the global profile used, impacting which data messages and fields are expected within the file. 4. Data size specifies the length of the data section in the file, which follows the header. 5. Data type. This is typically the ASCII string FIT, confirming the file format. 6. CRC, cyclic redundancy check, an optional field used for error checking the header. If the header is expanded in future versions, the CRC can validate that the header has not been corrupted. How data fields are defined in a FIT file. The actual data in a FIT file is structured in messages, each defined by what's known as a definition message preceding the actual data entries, data messages. Each field within a data message has a specific meaning, determined by the global FIT profile. The definition message specifies the type of data message, e.g. session, event, lap, the structure of the data message, what fields it contains, and in what format. Each field's data type, e.g. unsigned integer, string, any additional data such as units or constraints. This structured approach allows FIT files to be extremely flexible and expandable. New data types and messages can be added without disrupting existing applications, as long as those applications adhere to the defined protocols for unrecognized messages. They can simply ignore them. Conclusion. While the FIT file format is complex, its design allows for a wide range of data to be compactly stored and transferred between devices from different manufacturers. The use of a global profile ensures that any device or application that understands the FIT protocol can parse and interpret the data correctly, regardless of where it came from. The header provides essential information for correctly processing the rest of the file, ensuring that the data is handled appropriately according to the specifications of the protocol version and profile version used.
Okay, so if I have the protocol version and the profile version, should I just be able to look up online or in some sort of repository what the contents of a specific data file actually contain?
Yes, you're on the right track. If you have the protocol version and profile version from a FIT file's header, you can refer to the official documentation or an online repository to determine the exact structure and meaning of the data stored within the file. Each version of the FIT protocol may introduce changes to how data is formatted and what each field represents, so having the correct version information is crucial for accurate interpretation. Here's how you can proceed to understand the contents of a specific FIT. Steps to interpret FIT file data. 1. Refer to the FIT SDK documentation. The FIT SDK provided by Garmin, or potentially other sources if they've implemented the FIT protocol, will have comprehensive documentation. This includes detailed explanations of what each field in various types of messages, like activity, session, lap, etc. represents based on the profile version. 2. Use the FIT SDK. The SDK includes tools that can help you generate code or libraries tailored to interpret FIT files based on the specific protocol and profile versions. This is useful because it automates much of the interpretation process and ensures you're working with the correct definitions as per the FIT standards. 3. Look up the profile version. Each profile version corresponds to a set of definitions for different types of data messages and fields within those messages. By looking up the profile version, in your case, 2170, you can find out what each data field, like field 1 in your example, represents. These definitions are typically found in the global profile documentation within the SDK. 4. Online resources and community forums. Besides the official SDK, there might be community-driven resources or forums where developers discuss handling FIT files. These can be invaluable for getting practical advice and examples of how to work with complex data structures. Example: interpretation. Given your data example, you will need to find out what field 1 corresponds to in the context of the specific messages where it appears. The numbers, e.g. 6730764, 126223364, are likely encoded values for a particular type of data, which you can decode using the FIT profile specifications. For example, definition message determines the structure and meaning of subsequent data messages. Data messages contain actual values for fields defined in the definition messages. Practical usage: decode the FIT file. Using tools provided in the SDK, decode the FIT file to read the raw data. This will typically convert the binary data into a more readable format, aligning it with the specifications in the SDK. Identify message types and fields. Using the decoded data, identify the type of each message and what data fields it contains. Match these to the definitions in the FIT profile to understand what each data point represents, e.g. heart rate, GPS coordinates, timestamps. By following these steps, you can turn the raw data from a FIT file into actionable insights or display it in a user-friendly format. If you're developing an application that needs to process or display data from FIT files, using the SDK and following its guidelines will help ensure compatibility and accuracy in how the data is handled.
Still don't understand why do I need to download the SDK, considering it has a very long terms and conditions thing. It's definitely not an open source thing. Is there something else that I can use, or just look up a specification file that meant to be a single text file that describes the current protocol version and the profile version of the data file?
If you're hesitant to use the Garmin FIT SDK due to its licensing terms or because it's not open source, you can indeed explore other ways to interpret FIT files without directly using the SDK. Here are a few strategies you might consider. 1. Open source libraries. There are open source projects and libraries that can parse and interpret FIT files. These libraries often reverse engineer the FIT protocol or use publicly available documentation to handle FIT data without needing the official Garmin SDK. Some of these projects might be available on platforms like GitHub, where developers share their implementations in languages like Python, Java, or Java. For instance, Python, there might be Python packages that can parse FIT files. You can look for these in the Python package index, PyPI. JavaScript nodes community-driven NPM packages that parse FIT files. 2. FIT protocol documentation. Sometimes detailed protocol documentation is available online through community forums or other developers who have worked with FIT files. This documentation might include breakdowns of different message types, fields, and how to interpret each based on the protocol version. Forums and community groups, places like Stack Overflow, Reddit, or even specific forums for developers working with sports and fitness data might have posts or threads discussing the FIT protocol. Technical blogs and articles. Some developers or companies working with FIT files might publish their insights and breakdowns of the protocol, which could be based on their analysis or reverse engineering efforts. 3. Construct your decoder. If you have the protocol and profile versions and you can access a basic description of the FIT file structure, like the one you mentioned, you could attempt to construct your own basic decoder. This would involve Reading the binary data. Open the FIT file in a binary format and read through the data according to the FIT structure: header, records, messages. Interpreting data according to documentation. Use any available documentation to interpret what each byte and field represents. This could be complex and prone to error without the official SDK, but might be feasible for specific or simpler data readings. There might be third-party tools or services that can decode FIT files for you, providing a GUI or a more accessible interface to view and analyze the data without diving into code. Advantages and disadvantages. Advantages. Using open source tools or building your own decoder gives you more control over the data processing and might avoid legal licensing complications. It also enhances your understanding of the data structure. Disadvantages. Without the official SDK, you may miss out on certain optimizations or official updates to the FIT protocol. Your implementation might also be less reliable or accurate, especially for newer versions of the protocol or more complex datasets. Conclusion. Ultimately, the decision depends on your specific needs, the complexity of the FIT files you are dealing with, and your capacity to manage potential technical challenges without official support. If you are working on a project that requires high accuracy and reliability, or if you're handling a wide variety of FIT file types, using the official SDK or a robust open source alternative is advisable.
Okay, so we got some files. Yeah, we do want to understand what's in it. So we have version, profile. What's it? 170. What? There is everything except 170. Oops. Yeah, it's all the different devices. Set Vivo active. Vivo. It's actually meant to be a different profile version. Are we loading the correct file? Not sure we're loading the correct file. Can we display the file name as well that we are currently loading? Okay, a couple of things. First of all, I have this readme file, which meant to be a JavaScript parsing tools for the data files we are working with. Now, also another thing is, did you mention that we can use Node.js to actually use that original JavaScript file from the CDN? Can you provide more information on that one? Also, in our current version of the code, can we display the file name on the front page and potentially any other additional details, either from the header of the FIT file or...
Based on the README file you provided, the Garmin FIT JavaScript SDK indeed provides a robust toolset for parsing FIT files in a JavaScript environment, including Node.js. Here's how you can leverage this SDK along with Node.js. Using the FIT JavaScript SDK with Node.js. 1. Install Node.js. Make sure you have Node.js installed, v14.0 or higher as required by the SDK. 2. Install the FIT SDK. Use npm to install the Garmin FIT SDK. Bash npm install at garmin/fitsdk. 3. Import and use the SDK. You can import the necessary components from the SDK to start working with FIT files. Here's a basic example of how you could use it in your Node.js application. JavaScript import decoder stream profile utils from @Garmin's fitsdk. Create a stream from a byte array, assuming you have the bytes of a FIT file. Const bytes equals to FIT file bytes here. Const stream equals stream.from byte array bytes. Create a decoder instance, const decoder equals new decoder stream. / check if the stream is a valid FIT file, console.log is FIT plus decoder.isFIT. Read and decode the FIT file, const messages errors equals decoder.read. Output errors and messages, console.log errors, console.log messages. Displaying file name and header details on the front page. To display the file name and additional header details from a FIT file on the front page of your application, you can modify your server-side code to read these details from the FIT file and pass them to the front end. 1. Read FIT file header. Modify your Node.js backend to open and read the FIT file, extracting the header details. 2. Pass details to front end. Send these details to your front end, potentially through an API endpoint or during page rendering. 3. Display on front end. Use JavaScript to display these details on the web page. Here's a conceptual example of how you might implement the server-side logic in Node.js. JavaScript const fs equals require fs. Const decoder stream equals require at garmin/fitsdk. Function to read FIT file header, function read FIT file header file path. Const file buffer equal fs.read file sync file path. Const stream equals stream.fromBuffer file buffer. Const decoder equals new decoder stream. If decoder is FIT, const messages errors equals decoder.read. Return valid true messages errors. Return valid false. Example usage const header info equals read FIT file header, path to your FIT file.fit, console.log header info. This server-side logic reads the FIT file and decodes it using the Garmin FIT SDK. You can extract specific header information from the messages object and then send this data to your front end to be displayed. Conclusion. By integrating the Garmin FIT SDK with Node.js, you can robustly handle FIT files in your application, enabling detailed data analysis and display. This setup allows you to parsing and interpretation of complex FIT files, potentially enhancing the user experience by providing meaningful insights directly on your web application's front page.
Yeah, I'm not sure why it's so complicated, considering, yes, I get it, there's a binary file, but then the header should have most necessary information. Okay, I think the header still should have all the necessary information to be able to decode this file. Can we look again at the code and also display the file name on the front page? Also, instead of choosing a file, can we just have a drop-down menu with all the existing data files that are available in the data folder?
To implement a drop-down menu that lists the FIT files available in your static/data directory on your server and allows users to select one for parsing, you will need to make some changes to your server-side setup to dynamically list these files and modify your front-end HTML and JavaScript accordingly. Step 1. Server-side file listing. You will need a server-side route in your Flask application to list the files in the static data directory. This route will return the file names as a JSON response that can be consumed by your front end. Here's an example of how you might implement this in your Flask application. Python from Flask import Flask JSONify import os app equals Flask app.route/list FIT files def. List FIT files directory equals os.path.join app.static folder data. Files equals f for f in os list dir directory if f turn JSONify files. If tor name ape equal with score main score app.run debug true. Step 2. Front-end modification. On the front end, you will modify the HTML to include a drop-down menu and update the JavaScript to fetch the file list from the server, populate the drop-down, and handle the file selection. HTML changes. Replace the file input with a drop-down menu. HTML select ID equals file drop-down option, select a FIT select button, on-click fetch and parse file. Parse FIT file ID, file name, header output. JavaScript changes. Add JavaScript to fetch the list of files when the page loads and update the drop-down menu. Also, modify the existing functions to handle file selection from the drop-down. JavaScript document.add event listener, DOM content loaded, event, fetch file list. Const dropdown is document get element by ID, file dropdown. Dropdown.add event listener change function, const selected file equals this.value. If selected file, fetch and parse file selected file. Document.getElementById by ID file name text content equals loaded file selected file. Function fetch file list, fetch/list FIT files, then response equals response.json. Then files equal const dropdown equals document get element by ID file dropdown. Files.for each file equals const option each document create element option. option.value equals file, option.textContent equals file, dropdown.append child option, .catcher equals console.error, error loading fit files, error. Function fetch and parse file, file name, fetch /static / file name, then response equals response at array buffer, then array buffer equal parse fit data array buffer, .catch error, .get element by ID output text content equals error loading file error. Certainly. Here is the updated version of the entire HTML and JavaScript code for your application, incorporating the changes to use a dropdown for selecting fit files directly from the server's static/data directory. HTML code. HTML, HTML lang head. Meta charset UTF-8, meta name bool viewport content width device width, initial scale fit file processor. Link rel style sheet URL for static file name equals css/style.css. Body fit file processor select ID equals file dropdown option select a fit file. On click fetch and parse file, parse fit file. Pre-ID header output, pre-ID equals output. Script source URL for static file name equals /app body JavaScript code JavaScript document.add event listener DOM content loaded event fetch file list const dropdown equals document.get element by ID file dropdown.add event listener change function const selected file of this value. If selected file and selected file equals select a fit file, fetch and parse file, selected file, document.get element by ID file name, text contents, loaded file, selected file. Function fetch file list, fetch /list fit files, then response.json, then files equals const dropdown x document.get element by ID file dropdown, files.for each file gets const option x document.create element option.value x file, option.text content x file, dropdown.append child option. .catch error console.error error loading fit files error. Function fetch and parse file file name fetch /static data's file name, then response equals response.array buffer, then array buffer parse fit data array buffer. .catch error document get element by output text content equals error loading file $all error console.error error loading file error. Function parse fit data array buffer const data view equals new data view array buffer let offset equals 0 try const header size with data view.get uint 8 offset equals 1. Const protocol version equals data view get uint 8 offset plus equals 1. Const profile version is data view get uint 16 offset true, offset plus equals 2. Const data size equals data view get uint 32 offset true, offset plus equals 4. Const file type equals string from char code, data view.get uint 8 offset, data view.get uint 8 offset plus 1, data view.get uint 8 offset plus 2, data view.get uint 8 offset 3. Offset plus 4. If file type equaled fit, throw new error invalid fit file. Document.get element by header output.text content equal JSON stringify. Header size, protocol version, profile version, data size, file type null 2. Offset equals header size. Const records equals. While offset data size plus header size die 2. Const record header equals data view.get uint 8 offset. Offset plus x1. If record header and 0
Problem with those feed files, the original ones, that they have all these silly names for warm-up exercise name. Like, no, don't care about that. Water type, fresh, salt. Okay. Tissue mode time. This is a Ballman's decompression algorithm version C. Okay. Dive gas status. Disable, enable, backup only, dive alert. Can get rid of all the diving stuff. Okay, sleep level is interesting. SPO measurement, more diving, check for dive, more diving stuff. Sounds of information embedded in or disabled in dive. What are these numbers? Yeah, I'm interested obviously in the device that I have. Obviously some older device, and that's the one I have. What's 256? Battery voltage. No, wait. Those are the different devices that again I don't particularly care about. Yeah, it seems like the device I have is not actually there. 2170 is nowhere to be found, and mine is actually called, so that's how I know this is inaccurate information, because mine is actually called Vivo Active. I mean, how many possibly like devices they can possibly have? 4, small or large, small Asia, large Asia, OLED. Yeah, okay, doesn't really matter though. Well, the profile version being returned is different. It's not actually existent in the list. Then even if you do have a number that exists, then there is no explanation as to, why would the lookup be any different to anything else. So it should be those fields. So say this number here, and no. Okay, that's the profile. Good luck, JS. Let's get rid of it for a sec. Let's move in the whole folder, source and test. Let's search, say, one of those numbers. Yeah. Any other number? Package. That doesn't have much. Profile. A message number. This is rather complicated, isn't it? I think there might be something. Can we refresh this page? And the display position. Estonian grid system. What? Multisport. Include all sports. That's not interesting. Flying. Okay. No, that's fine. I mean, I didn't even think. Yeah, so first we learned that there's like a gazillion of these wearables. They're all supposedly different because they're recording different things. Auto scroll, step duration, step target, goal, device generated social network. No. Battery status. Okay, that could be important. Well, not really. It's either working or not. Like, why do we care? Have some heart rate, beats per minute. What is it doing? Plus 100. It's like indicating 0 to 100, above 100. Yeah, I think it does like high intensity is the workout, is the number of minutes in above 100 beats per second. Actually not wearing it at the moment because it's pretty annoying on the wrist all the time. Wait, I suspect those values might be hexadecimal or something. Why? Sometimes they are, sometimes they aren't. Can you read this file? Heart rate type, normal, irregular, course capabilities. No, I can't directly read files like Excel spreadsheets. That's not cool. That's not cool. Flight time, max met heart rate source. It's a wrist or chest strap. Yeah, there's a lot to it, which is good, but yeah, this is what we have so far. Yeah, we don't really need this button, do we? Pilot explain this. The provided JavaScript code defines two classes, accumulate field and accumulator, which are part of the system likely designed to handle processes that according to the the FIT protocol. Yep. Accumulated class value specific field. This is necessary extensibility and complexity. Yeah, it's way too complicated. All I need to know is what the fields are. Field 1. I suspect these numbers are not in the correct format. Okay, this is interesting. Right, we have the different feed files, then different devices and everything, aren't they? But then we also have, I guess, the same files converted to CSV. Can we update the file and folder structure for the entire project? It's supposed to be fetching all the files and folders in the folder in the project. So we have FIT data, by templates, index.html, static.js, FIT parser. Yes, we're not actually using those. Now we would like to parse those CSV files. Yeah, all I need to know is what each one of those field labels actually means. Alternatively, we could look at the CSV files because some of them were already converted. So we're trying to parse FIT files. I don't want to show any copyrighted stuff, but essentially it's files from one of those variables. There are a gazillion of different types. FIT file meant to be. Can you quickly explain in one continuous paragraph what is it we are trying to do and what problems we are facing? Maybe another paragraph on the overall objective of what this could be used for.
We are working to develop a web application that efficiently handles and parses FIT files, which are a specialized format used predominantly for storing data from fitness devices like GPS watches and cycling computers. Our goal is to allow users to easily select and analyze these files directly from a web interface, improving access and interaction without the need for detailed technical knowledge of the underlying data structure. By integrating a drop-down menu that lists available FIT files stored on the server, users can conveniently choose which file to process. The application then reads and displays essential metadata from the file's header, like protocol version and file size, and processes the content to extract and display specific data points. However, we've encountered challenges, particularly in parsing the FIT file format correctly, as it requires precise handling of its binary structure and understanding of how data is organized within it, which is crucial for accurate data interpretation and display. This tool could be incredibly useful for athletes, coaches, and enthusiasts in the sports and fitness community, providing an easy-to-use platform for reviewing performance data, planning training sessions, and analyzing detailed metrics that help in improving athletic performance.
Can you look at this Decoding.js? Isn't this all we need to be able to parse the FIT files correctly? Also, can you touch another paragraph on the fact that we also have CSS files, so essentially FIT files converted to CSS. So should we be using those instead? They should be more straightforward to use. They're not binary.
The provided decoder.js file contains a comprehensive JavaScript module for decoding FIT files, typically used in fitness devices to store activity data. This decoder manages the intricacies of the FIT file format, handling both data integrity checks and the extraction of meaningful data from the binary format. This file is a crucial part of a system designed to allow users to upload and interpret data from their fitness activities directly through a web interface. This script utilizes several key classes and utilities to interpret the structure of FIT files, including accumulator, bitstream, keyer calculator, and various utility classes that help manage data conversions and integrity checks. The main class, decoder, orchestrates the reading of streams, handling of file headers, and processing of both standard and developer-defined data messages. It supports features like expanding subfields and components, applying scale and offset to data, and converting data types for easier readability. Concerning your question about using CSS files, it seems there might be some confusion. CSS files are used for styling web pages and wouldn't be involved in data processing or conversion of binary FIT files. They cannot be used as an alternative to processing FIT files, which are binary and require parsing to extract any data. The aim is to create an accessible tool for users to easily visualize and analyze their fitness data without needing to understand the underlying binary format.
So I made the CSV files. So there is a corresponding CSV file to every FIT file in a separate data folder. How could we use those? Also, from the decode JavaScript file, how can we parse what we currently have in a better way?
The presence of corresponding CSV files for each FIT file presents a simpler alternative to handling FIT file parsing, especially if the main goal is data visualization and analysis. CSV files are inherently easier to work with because they are text-based and can be directly read and processed by numerous tools and libraries, including web technologies and data analysis software. This eliminates the need for complex binary decoding as required for FIT files. Here's how you could utilize the CSV files. 1. Direct display and analysis. Since CSV files can be easily read into most programming environments, they offer a straightforward path for data manipulation and visualization. You could use JavaScript libraries like D3.js or Plotly to directly read the CSV data and render charts or tables on the web interface. 2. Data handling. For the web interface, you can utilize JavaScript's built-in fetch API to retrieve CSV data from the server, and then use something like d3.csv parse or papa parse to convert the CSV data into a usable format for the front end. 3. Drop-down menu for file selection. Incorporate a drop-down menu on your website that lists all the available CSV files. When a user selects a file, the web application can fetch the file, parse it, and display the data in a human-readable format or graphical representation. 4. Enhanced data interaction. With CSV files, users can filter, sort, and perform other data manipulations without extensive processing overhead. You can provide interactive elements on the website that allow users to customize how they view the data, such as selecting which columns to display or applying filters to the dataset. 5. Server-side processing. If server-side processing is available, you can use it to pre-process CSV files into more manageable chunks or summaries before sending them to the client, reducing the load on the user's device and potentially enhancing the user experience. For your JavaScript decoder, if you still need to work with FIT files for any reason, e.g., because they contain data not available in CSV.
Okay. So the FIT files, when selected on the front page, should display the contents of the header. And when we're selecting a corresponding CSV file, well, then we do something else. We actually display the contents of the file. I'll give you an example of one. See how we can change the code and display the contents in an interesting way. If you have any jokes, by the way, go for it. Don't be shy. So we have the first 25 lines from.
For the functionality you're describing, where selecting a FIT file displays header information and selecting a CSV file shows the file contents, we can modify the existing web application to accommodate this dual behavior. Here's how we can approach it. 1. Drop-down menu for file selection. Enhance the current file input mechanism to include a drop-down menu listing all available FIT and CSV files. This allows users to select the file type they want to view directly from the interface. 2. Display FIT file headers. For FIT files, parse only the header to display essential metadata like protocol version, profile version, and data size. This gives a quick overview of the file's structure without delving into the detailed data records, which might be complex and not immediately necessary. 3. Display CSV file contents. For CSV files, read and display the contents directly. Since CSV files are text-based and simpler to parse, you can present them in a table format on the web page, allowing users to view the data in a structured and easy-to-understand manner. 4. Interactive data visualization. For CSV files, consider implementing interactive data visualizations. Tools like Chart.js or Google Charts can convert CSV data into dynamic graphs and charts, enhancing the user experience by providing more insightful views of the data. Here's an example of how you might modify the HTML and JavaScript to implement this. HTML update. Include a dropdown to choose between the file activity developer data.csv is structured to provide a detailed breakdown of data recorded in a FIT file format, but represented here as CSV for easier processing. Each line represents a distinct record, either defining the structure of upcoming data, definition records, or presenting actual data, data records. Each record is described with various fields, such as type, local number, message, and multiple field value units, triples that describe the data being captured. Definition lines. These lines outline the structure of the data records to follow. For example, the file ID and device info messages define what fields, like type, manufacturer, product, etc., to expect in subsequent data records. Data lines. These contain the actual values for the fields defined in the preceding definition lines. They provide specific values, such as the type of device, timestamps, and other data captured by the device like heart rate, speed, etc. The content of this CSV file suggests that it's primarily used for managing and decoding data related to fitness activities and device configurations. The CSV format here allows for more straightforward manipulation and visualization of the data compared to the binary FIT format, making it accessible for data analysis and application development purposes. You can use this CSV to display the data on a web page by parsing it into a table format, allowing users to visually inspect and analyze their fitness data. For more interactive usage, you could implement features like sorting, filtering, and detailed visualizations, graphs, or charts using JavaScript libraries such as D3.js or Chart.js, enhancing the user experience by providing insightful views and breakdowns of the fitness data. This approach leverages the ease of handling CSV in web technologies, bypassing the complexities involved in parsing binary FIT files directly in the browser. It simplifies data handling and enhances performance, especially useful when dealing with large data sets typical in fitness tracking scenarios.
Any suggestions as to how to change the code exactly so the data can be viewed in a useful manner?
To display the CSV data in a useful manner on your web application, you can create an interactive table with sorting and filtering capabilities. This setup can be further enhanced with graphical visualizations for a more insightful analysis of the data. Here's a step-by-step guide to implement these features. Now, number 1, update the HTML interface. Add a section for displaying the data table and potential charts. Here's an example HTML layout. HTML.html, heading meta charts at UTF-8, name viewport content width, device width, initial scale, 1-point viewer, CSV data viewer, link rel style sheet, ref style, CSV data viewer. Select ID equals file selector on change, load CSV data. Options for CSV files populated dynamically. Div item scriptia //cdn.jsdeliver.net d3m/d body. 2. JavaScript for loading and displaying CSV data using d3.js to load and display the CSV data simplifies the process. Here's how you can implement it. JavaScript document.addEventListener DOM content loaded function populate file dropdown / populate dropdown with CSV file names. Function populate file dropdown const file selector equals document.getElementById file selector. Example files replace with dynamic fetching if needed. Const files equals activity developer data.cscsv. Files.for each file to let option equals document.create element option, option.file, option.text equals file, file selector.append child option. Function load CSV data, const selected file to document get element by ID, file selector value, d3.csv slash path slash data dash selected file, then function data, display data data. Function display data data, const container equals document get element by ID, data table. Container.inner HTML equals slash clear previous contents. Const tables d3.select container append table. Const thead equals table.append thead. Const tbody equals table.append tbody. Populate the header the.append or th select all data object.keys data 0.enter.append text d equal d. Create a row for each element in the data. Const rows tbody.select all tr. Create a cell in each row for each column rows.select all td. Data function row return object.keys row map column equal row column .enter.append td .text dd. Notion number 3.
Can you summarize the changes made, and also can you mention what model are we using at the moment? I think we switched from GPT-4 to 4 not 4.0. Also, but that's not important. Moving on to we actually need to fix the JavaScript. So can you generate all the instructions for how to generate the code from scratch? We might be using another AI to actually write the code. Selecting an odd D3.js library. The code seemed to be there. Forgot about styling. It just timed me out from... I think the timeout expired already. Can you just give a continuous text summary of the code changes that were recently made? I don't know which model I'm using, 4.0 or 4. Yeah, I did notice some difference between them, but I don't. Yeah, by the time I'll figure it out, they will change to whatever GPT 5, 6, 7, whatever. They'll be doing like the iPhone business.
Certainly. Recently, we made several changes to the code to enhance the functionality and user interface of the FIT and CSV file processor. First, we updated the HTML structure to include a drop-down menu that allows users to select existing FIT or CSV files from the static data folder. This replaces the previous file input method. We added a new function in JavaScript to dynamically populate this drop-down menu with the names of the available files. Additionally, we implemented functionality to load and parse the selected file using D3.js, which is particularly effective for handling CSV data. We also modified the JavaScript code to display the contents of the selected CSV file in a well-structured table format on the front page. This included creating a table with a header row and dynamically populated rows and cells for each data entry in the CSV file. Furthermore, the code was adjusted to display relevant details from the FIT file header, including the file name, protocol version, profile version, data size, and file type, directly on the front page. These enhancements ensure that users can easily view and interact with the contents of both FIT and CSV files in a user-friendly manner.
Go back to GPT-4, it seemed to be performing a bit better. Okay, a couple of things. The JavaScript code is much shorter. What happened to all the previous stuff? Did we drop attempting parsing the original binary data files, the FIT files, or so we're just moving to parsing CSV, or well, even that doesn't work at the moment. We just get an empty screen. There's something wrong in the code. Can you fix that for us? That would be great, so we can move on. If you have any jokes relevant to the topic, don't be shy. There's a couple of things. Not all the CSV data files were loaded from the data folder. Can we regenerate the Python app by Flask backend code?
It looks like the Flask app is not loading all CSV files from the data folder as expected. To address this, I'll guide you through generating the Python Flask backend code that dynamically lists all CSV files in the data folder and exposes them for your front end to consume. This will help ensure that all files are available for selection in your web application. Here's how to adjust your Flask app.py to correctly handle the listing and serving of CSV files from the static directory. Updated app.py, Python from Flask import Flask, JSONify, render template, import os app equals flask.route// def index, return render template index.html, add app.route list CSV files, def list CSV files, directory equals os.path join app.static folder data. Ensure your data is within the static directory files equals f for f and os.lister if f ends with .csv, return JSONify files. If core name equals run debug equals true. Explanation. 1. Route for listing CSV files. The route/list CSV files dynamically scans the data directory within the static folder for any files ending with .csv and returns their names as a JSON list. 2. Use JSONify for JSON response. This Flask function correctly sets the response headers to indicate that the response content type is JSON, which is ideal for JavaScript fetch operations. 3. File directory. Ensure that the path to the directory is correct and that the files are placed within the static data directory as expected. Flask static files are generally served from a directory named static by default. 4. Testing. After updating the code, restart your Flask server to apply the changes. Make sure your front-end JavaScript is correctly requesting this new route to fetch the CSV file list. Front-end JavaScript update. Make sure your front-end JavaScript makes a request to the updated endpoint. Here's a simple fetch example to integrate into your JavaScript. JavaScript function load CSV file list, fetch/list CSV files, then response.json, then files, const selector document det element by ID, file selector, files.for each file, let option equals document.create element option, option.value equals file, option.text content equals file, selector.append child option, catch error equal console.error, error loading CSV files error, document add event listener DOM content loaded load CSV file list. Debugging. Check the browser console for any errors when loading the page. Use the Network tab in your browser's developer tools to see if the request to /list-CSV files is successful and returns the expected list of CSV files. These updates should ensure that all CSV files in your specified directory are dynamically listed in your web application's drop-down menu for selection and further processing.
Can you provide any suggestions as to how the data can be displayed in a better way? So potentially we would like eventually we would like charts and graphs instead of tables. If there is a table, it should be just a short summary. Can you make any suggestions? If you have any jokes in mind, don't be shy.
For displaying data from CSV files in a more engaging and insightful manner, integrating charts and graphs can significantly enhance the interactivity and readability of your data. Here are some suggestions on how to approach this, along with a lighthearted joke to keep the mood up. Suggestions for data visualization. 1. Use JavaScript libraries. Consider using popular JavaScript libraries like Chart.js or D3.js for rendering charts and graphs. These libraries offer extensive documentation and examples to help you create everything from simple bar charts to complex data visualizations. 2. Summary tables with data-driven graphs. Summary table. Display key metrics or summaries as a small table for quick insights. For example, showing total counts, averages, or other statistics that provide an overview of the dataset. Graphs for detailed analysis. Use line charts to show trends over time, bar charts for comparisons among categories, and pie charts for showing proportions. 3. Interactive elements. Enhance user engagement with interactive elements such as tooltips, zooming, and clickable legends, which allow users to explore data in more depth. 4. Dashboard layout. Organize your visualizations and tables within a dashboard layout for better navigation and data storytelling. Frameworks like Bootstrap can be used to create responsive grids for layout. Implementation example with Chart.js. Here's a basic example of how you might set up a bar chart using Chart.js to display data from a CSV file. HTML setup. HTML doc.html meta charset UTF-8. Meta name and viewport content width device width and data dashboarded. Script /cdn.jsdeliver.net /npm/nem/want. Data visualization H. Canvas ID my chart canvas. Path to a splash app tag. JavaScript app.js, JavaScript document.add event listener, DOM content loaded function, fetch /path to your data.csv, then response for PSV parse CSV, then data const ctx equals document get element by id chart.get context 2d, const my chart equals new charts, type bar, data labels, data.labels, datasets, labels # votes, data.values, background color RG55 99 132 0.2, border color RGB at 255 99 132 1, border width 1, options scales Y begin at 0 true, function parse CSV const lines equals CSV sv.split n, const values equals lines.for each line index if index 0 and line skip header const parts equals line.split labels push parts 0. Assume the label is in the first column, values.push parse float parts 1. Assume the value is in the second column, return labels, values.